an engine that looked like the future but felt like the past. The Chevrolet 350 TBI throttle body injection arrived in 1987 as General Motors' answer to the fuel injection revolution, promising the reliability of electronic fuel delivery with the simplicity of a carburetor. It was supposed to be the best of both worlds. For nearly a decade, from 1987 to 1995, the TBI 350 powered millions of American trucks, vans, and full-size cars. It delivered consistent starts, handled altitude changes without missing a beat, and met increasingly strict emissions requirements. But here's where the story gets complicated. While the TBI system solved some problems, it created entirely new ones that mechanics are still cursing about today. So why did an engine that seemed like such a logical step forward become one of the most controversial power plants in GM history? And what can the TBI's complicated legacy teach us about the messy transition from mechanical to electronic automotive systems? Historical context and development. The Chevrolet 350 TB. I wasn't born from inspiration. It was born from desperation. By the mid-1980s, General Motors was caught in a perfect storm of regulatory pressure, technological change, and competitive challenges that demanded immediate solutions. The corporate average fuel economy standards were tightening, emissions regulations were becoming more stringent, and foreign competitors were demonstrating that fuel injection could deliver both performance and efficiency. Meanwhile, GM's traditional carburetor-based engines were struggling to meet these new demands while maintaining the drivability customers expected. GM had already experimented with more sophisticated fuel injection systems. The Corvette's cross-fire twin-throttle body setup from 1982 to 1984 was complex and expensive. The later tuned port injection system introduced in 1985, Corvettes delivered impressive performance but required extensive redesign of intake manifolds and was costly to manufacture. What GM needed was a bridge technology, something that could deliver the benefits of fuel injection while using existing manufacturing infrastructure and keeping costs reasonable. The answer was throttle body injection, a hybrid system that combined electronic fuel injectors with a carburetor-style throttle body. For the 350 cubic inch small block, this meant 210 horsepower and 300 pound-feet of torque in factory specification, respectable numbers that maintained the V8's reputation while meeting modern requirements. The Golden Age. When the TBI 350 debuted in 1987 Chevrolet and GMC trucks, it represented a massive shift in American automotive technology. For the first time, millions of working vehicles would rely on computer-controlled fuel delivery instead of purely mechanical carburetors. The initial reception was largely positive. Fleet operators discovered that TBI-equipped trucks started reliably in all weather conditions, something that had been hit or miss with carburetors in extreme temperatures. The system automatically compensated for altitude changes, eliminating the carburetor jetting issues that plagued trucks operating in mountainous regions. Fuel economy improved modestly but measurably. While the gains weren't dramatic, typically 1 to 2 miles per gallon over comparable carbureted engines, they were consistent and helped manufacturers meet CAFE standards. More importantly, the fuel delivery remained precise throughout the engine's operating range, providing smoother acceleration and more predictable performance. The TBI system's diagnostic capabilities, while primitive by today's standards, were revolutionary for their time. The check engine light could alert drivers to problems, and mechanics could retrieve basic trouble codes using simple jumper wires. No expensive scan tools required. From a manufacturing perspective, TBI was brilliant. GM could use existing intake manifolds, cylinder heads, and assembly line processes while adding electronic fuel control. The transition from carburetor to TBI required minimal retooling, making it economically attractive compared to more sophisticated port injection systems. the 350 TBI found its way into an enormous variety of applications. Silverado and Sierra pickups, Suburban and Tahoe SUVs, Express and Savannah vans, and even some passenger cars like the Caprice and Roadmaster. Technical brilliance. The TBI system's technical approach was elegantly simple, which was both its greatest strength and its fundamental limitation. Unlike more sophisticated port injection systems that delivered fuel directly to each cylinder's intake port, TBI used just 2 injectors mounted in the throttle body to feed all 8 cylinders. The electronic control module used a speed density calculation method to determine fuel requirements. By measuring manifold absolute pressure and engine RPM, the computer could estimate how much air the engine was ingesting and calculate the appropriate fuel delivery. Additional sensors provided correction factors. The coolant temperature sensor adjusted for cold start enrichment, the throttle position sensor detected acceleration demands, and the oxygen sensor provided feedback for fine-tuning. This approach had significant advantages. The system was far simpler than port injection, using fewer components and requiring less sophisticated manufacturing. Troubleshooting was relatively straightforward. Mechanics could actually see fuel spray from the injectors, making diagnosis more intuitive than with hidden port injectors. However, the TBI system's design created inherent compromises. Fuel had to travel through the entire intake manifold before reaching the cylinders, leading to uneven distribution and response delays. The wet manifold design meant that fuel could pool or vaporize unevenly, affecting cylinder-to-cylinder balance. The swirl port cylinder heads used with TBI engines were optimized for emissions compliance rather than performance. While they helped the engine meet pollution standards, they severely restricted airflow, limiting power potential. The throttle body itself flowed approximately 390 cubic feet per minute with injectors installed, adequate for the engine's modest power output, but restrictive for any performance modifications. Challenges rise by the early 1990s. The honeymoon period with TBI was ending. What had initially seemed like an elegant solution was revealing itself to be a troublesome compromise that satisfied no one completely. The most immediate problem was drivability. While TBI engines started reliably, they often exhibited frustrating issues that were difficult to diagnose. Idle surge, rough running, poor throttle response, and inconsistent fuel economy became common complaints. Unlike carburetors, which mechanics could understand and adjust intuitively, TBI problems often required systematic testing of electronic components. The diagnostic challenges were particularly vexing. The TBI system's primitive computer wasn't sophisticated enough to detect many problems that affected drivability. An engine could run terribly without setting any trouble codes, leaving mechanics to guess at solutions. This led to the infamous parts cannon approach, replacing multiple components hoping to stumble upon the actual problem. Fuel delivery inconsistencies plagued the system. The speed density calculation method was inherently imprecise, relying on assumptions about air density and manifold efficiency that didn't always match reality. Vacuum leaks, EGR problems, or worn intake gaskets could throw off the calculations, causing rich or lean running conditions that were difficult to trace. Most damaging to TBE's reputation was its timing in automotive history. The system arrived just as more sophisticated port injection became affordable, making TBI seem outdated almost immediately. The transition. The writing was on the wall for TBI by the early 1990s. General Motors had already demonstrated superior technology with their port injection systems, and the cost differential was shrinking rapidly. The question wasn't whether TBI would be replaced, but when and how quickly. The transition began with GM's premium applications. The LT1 engine, introduced in 1992 for the Corvette and later used in Camaros and Firebirds, featured sophisticated sequential port injection that delivered dramatically better performance and drivability than TBI. The contrast was stark. The LT1 produced 300 horsepower compared to the TBI 350's 210, while also providing smoother operation and better fuel economy. Corporate pressure to improve fuel efficiency and reduce emissions was intensifying. The TBI system's primitive computer control couldn't compete with the precision of newer systems that could adjust fuel delivery dozens of times per second based on multiple sensor inputs. Onboard diagnostics were becoming more sophisticated, and TBI's limited diagnostic capabilities were inadequate for emerging requirements. Customer complaints were mounting. Service departments reported increasing numbers of drivability problems with TBI engines, particularly as they accumulated mileage. The system's reputation for being simple and reliable was giving way to frustration with hard-to-diagnose issues and expensive repairs. The automotive press was becoming critical as well. Road tests consistently showed that TBI engines delivered inferior performance and fuel economy compared to competitors' port injection systems. The technology that had seemed advanced in 1987 looked antiquated by 1993. General Motors made the strategic decision to phase out TBI in favor of more advanced systems. The 1995 model year marked the end for most TBI applications, replaced by the Vortec 5.7-liter with central port injection, itself a transitional technology that would soon give way to true sequential port injection. The transition wasn't entirely smooth. Early Vortec engines had their own problems, particularly with the Spider injection system that proved to be unreliable. Some mechanics and owners actually preferred the simplicity of TBI over the more complex systems that replaced it. The TBI era lasted just 9 years for the 350 engine, a remarkably short production run that reflected the rapid pace of technological change in the 1990s automotive engineering. Legacy and modern reality. Today, more than 25 years after the last TBI 350 rolled off the production line, the system's legacy remains deeply controversial. Depending on who you ask, TBI was either a reliable workhorse, unfairly maligned by complexity-obsessed mechanics, or a frustrating compromise that should never have been built. The pro-TBI camp points to the system's fundamental simplicity and field serviceability. Unlike modern engines with dozens of sensors and complex wiring harnesses, TBI problems can often be diagnosed with basic tools. Replacement parts remain readily available and relatively inexpensive. Many TBI trucks have accumulated enormous mileages with routine maintenance, proving the basic durability of the system. The anti-TBI faction emphasizes the system's inherent limitations and troubleshooting difficulties. They argue that TBI's simplicity is misleading. While the system has fewer components, diagnosing problems often requires understanding the interaction between multiple systems. The infamous TBI stare, mechanics looking helplessly at an engine that runs poorly but shows no obvious problems, became a running joke in the industry. Modern aftermarket companies have developed solutions for many TBI problems. Custom tuning chips can improve drivability and performance. Upgraded fuel pressure regulators, improved injector designs, and better diagnostic tools have addressed many original shortcomings. Some enthusiasts have even converted TBI engines to modern aftermarket fuel injection systems. The collector car market has developed an interesting perspective on TBI. While most enthusiasts prefer either carburetors for their simplicity or modern port injection for their sophistication, TBI occupies an awkward middle ground. Some restoration purists insist on maintaining original TBI systems, while others immediately convert to carburetors or modern EFI. The 350 TBI proved that sometimes the middle ground satisfies no one. It was too complex for carburetor lovers, too primitive for fuel injection fans. What do you think? Was TBI necessary progress or an expensive detour? Share your thoughts and subscribe for more automotive controversies.